Good afternoon to all. Let's start the session. Uh, so let's start the session. Okay. Let me share my screen. Recording is on. Okay, is the screen is visible? Can you please someone confirm?
Yes, sir.
Okay, fine. So the last week means this week 5 is related to your basically root locus. Okay. So let me quickly go through what is covered in the last week. So first of all, we have to deal with what do you mean by root locus, okay? Then how a root locus diagram will be plot, okay? What are the various rules of the root locus and how you will able to uh, plot, okay? So, so first of all, before starting anything, so what do you mean by root locus? Suppose the basic question. So what is the meaning of that? First you have, there are two things. One is roots, another is locus. Locus means path. And what do you mean by roots? Roots means this is closed loop pole path. Okay. So how your closed loop system and how the poles of the closed loop system will vary. Okay. In which paths they will move. Wherever the system is, you can say over damped, under damped, critically damped. So in all this response, how your system will vary, how the poles will move, from which point they will start, from which point they will end, okay, like that. Okay, you have to understand. It means root locus means how the poles and zero will be vary, okay, but how you will vary. So remember that this chapter is the last chapter of your time domain analysis, okay. So next week onwards, actually your frequency domain will start, where you will vary the omega here means the frequency you have to vary. But here in this root locus, remember that you have to vary your system gain, okay. So k is called the system gain, and you have to vary this k from 0 to infinity, and you have to observe that how your closed loop pole path will be vary when you varying your system gain from 0 to infinity. That is the definition of basically root locus, okay. So now you have already gone through the lectures, okay. So all the rules of the root locus have you aware about that, and how we are going to plot a root locus. So basically, if I say what is the purpose of the root locus, means what? Means how you will deal a question. Means what is the purpose of this storing the root locus? Definitely you have to find out the system gain. First point, you have to find out the system gain for your stability of the system. Sometimes your system will not be stable, then you have to find out the system gain for marginally stable, or sometimes at which value of k the system will be going to unstable. Means basically you have to find out your system gain and the first point. Again, the second point, you have to find out, suppose the system will be marginally stable, then you have to find out what is the frequency of oscillation. Okay, I told you last class, marginally stable means it is having a constant frequency of oscillation. You have to find out at what frequency it will oscillate. Okay, then you have to find out the system relative stability. So these are some key observation when you're going to read root locus. You have to be aware about that. I have to find out my system gain, I have to find out my frequency of oscillation, I have to find out my relative stability of the system. Okay, any doubt till now? Let me give a quick example before starting this question number one. Let me give an example. Suppose a transfer function is given by like that, k by s, and I am asking you to find out the root locus of this one. Can anybody tell me how we'll start this? Root locus means I am telling you that this is the closed loop pole path. Okay, so closed loop pole is called your roots, and path means your locus. So this combination is called the root locus. So first you have to find out the closed loop transfer function. So closed loop transfer function is given by 1 plus gh equal to 0. So this means 1 plus k by s equal to 0. So s plus k equal to 0. Okay, this is the first equation, auxiliary equation. Now the closed root locus tells that when you vary from k from 0 to infinity, how your pole should be moved. Let's say this is my k. I am varying from 0 to infinity, 0, 1, 2, 3, 4, like that. And how your s, the poles will be vary. So here in this equation, your poles will be minus k. So when I put 0, your s equal to 0. When I put k equal to 1, your s equal to minus 1, your s equal to minus 2, s equal to minus 3. It means the poles will be vary like that. When you put k equal to 0 at this point, and here your poles will be at k equal to minus 1, 1. This location is s equal to minus 1. When this k equal to 2, your poles will be at s equal to minus 2. So you can say that your closed loop poles will be vary in this direction. Okay, as you vary your poles. So these are the poles location. Okay, so it varies from k equal to 0. At k equal to infinity, your pole location will be minus infinity. So in the negative x-axis, it will vary. So this is your root locus plot. Is this point is clear to everyone?
Yes, sir.
So now my point is that I'm just taking another example here, okay, for understanding that is this definition is always true or not. Let me give a second example. Gs equal to k divided by s square. So now I'm drawing the characteristic equation again. Hence root locus means closed loop pole path. So find out the closed loop transfer function. So 1 plus gh equal to 0. It means s square plus k equal to 0. So your s equal to plus minus j root k. Okay, these are your closed loop poles location. So now you vary from k equal to 0 to infinity, again the same, and s equal to plus minus j root k. Put the value of 0 here, k. You will get s equal to plus minus j root 1. Again 1 is equal to plus minus j root 2. Again up to infinity you vary your k. So s equal to get plus minus j root infinity. Now if you draw the closed loop of this path, then at k equal to 0 means at origin, your poles will be located at somewhere here, because these are complex conjugate. So one will be j root 1, another will be minus j root 1. So at this every point here, k equal to 0. This point also k equal to 0. Now when you vary k equal to 1, it will vary plus minus j root 2 in somewhere here. Okay. So this will be minus j root 2 and this will be plus j root 2. Likewise, at this point your k equal to 1, at this point your k equal to 1. So if you vary similarly from k equal to 0 to infinity, so you will get a root locus path which will vary which will vary in the imaginary axis. Okay, so if I change my pen and I will show you, so the exact pole will be vary in this direction, in this direction. So this is the closed loop, this is the root locus diagram for this transfer function. Now I'm taking the third example. Let me quickly give the third example. Let's say gs is equal to k divided by s cube, and find out this closed loop root locus for this. Then what you will do? Again, you have to do the same. Find out the closed loop transfer function. So this will give you s cube plus k equal to 0. And here, can anybody tell me what are the poles location s1, s2, and s3? Okay. Here in this case, again, the next example I'm giving, gs equal to k divided by s4. Suppose you are encountering a fourth order system. Then 1 plus gs is equal to 0. So here you get s4 equal to 0. So what are the poles location? Similarly, gs is equal to k divided by s fifth. So closed loop transfer function equal to 0. So the closed loop transfer function is like that. So your poles location will be s1, s2, s3, s4, s5. We have to solve these equations. Okay. So you have to solve this equation. You have to solve this equation. You have to solve this equation. So how much time it will take to draw the root locus of a fifth order system? If you are doing by using the exact definition of root locus, is it easy to find out the root locus like this? Are you with me? Are you understanding what I'm going to say?
No, sir.
Means you are not on my same pitch, ma'am. Means are you following me?
Yes, I'm following you, sir.
Okay, then tell me whether you have to find out the root locus by using the definition of root locus will be easier or you're finding difficulty now. If you're not getting, then I'll explain. If you're getting, then it's fine. By using this definition of root locus, is it possible to find the root locus by finding the roots of a fifth order system, by finding the roots of a fourth order system like that? It is not.
No, sir.
It is not easy. Okay. So it's quite cumbersome process to find out the roots, and then you have to again vary k from 0 to infinity to find out the root locus. So, so that's why what is happening here. So whenever you are finding out the root locus, so we never prefer closed loop system. So what we are going to do here to finding out the root locus, we are using open loop transfer function rather than closed loop transfer function. Remember that you are finding out the root locus by using open loop transfer function, but you are finding out the root locus for a closed loop system, not for a open loop system. Means you are finding out the system stability for a closed loop system by using open loop transfer function, not the closed loop transfer function, because to finding out the root locus by using closed loop transfer function is quite difficult. Okay, you can observe from these definitions. So that's why we are using open loop transfer function to find out the closed loop, or sorry, we are finding out the root locus by using open loop transfer function of a closed loop system. This is, you can say, in alternatively. So what I'm going to say is root locus diagram is to find out the closed loop system by using open loop transfer function. Means we are finding out the closed loop system ka root locus, but by using open loop transfer function, not by using closed loop transfer function. That's the point. It should have to be clear from the first definition. Okay. So in every question, whatever the open loop transfer function is given, let's say this is question number 1. For this transfer function, we are not going to use the closed loop transfer function. It means I am not going to solve this 1 plus gs is equal to 0. Rather than I will directly use gs equal to 2k s plus 5 divided by s into s plus 13 into s plus 2 to find out my root locus. But how? The question is how. How can you do that? By using open loop transfer function, you are able to find out the root locus of a closed loop system. So how to do that? You have to convert your closed loop transfer function into open loop system. Okay. Then you have to observe that. To do that, let me give an example. Let's say I'm summarizing this. Let's say my open loop transfer function is like that. K into some numerator is there, some denominator is there. Okay. So if I told you that what is my open loop transfer function pole, then you can say that ds equal to 0. Similarly, my open loop transfer function 0, you can say that k into ns equal to 0, so ns equal to 0. So these are my open loop poles location. But I am saying that what is the closed loop transfer function poles then? If you will use this gh, so find out the closed loop transfer function. 1 plus gh equal to 0. So you will get the closed loop pole equal to ds plus k times of ns equal to 0. This is my closed loop poles, okay? But I want to vary my closed loop poles by varying k from 0 to infinity to find out the root locus. But let's give an example. Here the definition said that you have to vary your k from 0 to infinity. And first you find out k here. K is how much? Minus, what is the value of k? Minus ds divided by ns, right? Are you following, guys? Otherwise, I think if it is tough for you, then I will start directly with the question before giving a background. If you're understanding, then you are at the same page with me, then okay. Otherwise, if you don't follow, then please stop me at the point where you are not getting. I just want to relate that how you are going to plot the root locus by using open loop transfer function rather than closed loop function. Are you guys at the same page? Can anybody confirm that? Are you following me or not?
Yes, sir. Following, sir.
Yes, sir. Yes, sir.
Okay, then fine. So, so here this is the closed loop poles, but I am finding out k from this equation. Why I am finding out k? Because I want to vary my k from 0 to infinity to find out my closed loop poles location. So first, whenever you put k equal to 0 in this expression, k equal to 0 means it will gives ds equal to 0. So in this equation, this is the closed loop pole. This is the closed loop pole, which is ds plus k ns equal to 0. Now here in this equation 1, I am varying k equal to 0. When I put k equal to 0, I get ds equal to 0. So ds equal to 0 is nothing but my closed loop poles, which is equal to my open loop transfer function pole. You can see here on the right hand side, ds equal to 0 means open loop transfer function pole, which is nothing but when you put k equal to 0 in this equation 1, you are also getting ds equal to 0. And it means in this closed loop pole location, if you put k equal to 0, then you are getting an expression which is same as your open loop transfer function pole. It means, remember that when you are varying k from 0, and here you are coming to k equal to infinity, when equal to k equal to 0, your root locus will start at open loop transfer function pole, because you are getting the same expression ds equal to 0, and ds equal to 0 is nothing but open loop transfer function pole. It means at k equal to 0, your ds equal to 0. It means at open loop transfer function pole, your root locus will be start at k equal to 0. And at which point it will end? It will end at k equal to infinity. In this equation 1, if you put k equal to infinity, then you get ns equal to 0. Okay, if you put k equal to infinity, you get ns equal to 0, and ns equal to 0 is nothing but your open loop transfer function 0. That means when you put k equal to infinity, you reach an expression which is ns equal to 0, which is nothing but your open loop transfer function 0. It means I have correlated when I'm varying from k equal to 0 to infinity, my closed loop poles will be exactly same, and will start from open loop transfer function pole, and it will ends at open loop transfer function 0. You got my point? So you now got 2 points. One, at k equal to 0, your root locus will start at open loop transfer function pole, and where it will be end? It will end at k equal to infinity at open loop transfer function 0. Now you can tell me, in this equation, the question number 1, when you vary k from 0 to infinity, then how many branches does the root locus have? Can anybody answer me this question? So first tell me, in this question number 1, just I'm erasing the top version here. So here, at which point the root locus will start? Root locus static point. Can anybody tell me?
So from every pole
Yes
location,
equal
one
to
branch will start, sir.
Okay, open loop pole location. So now how many open loop poles are there here? S equal to 0,
3, sir. 0, minus
S equal to
13, minus
minus
2.
13, and S equal to minus 2. Now where it will end? End is open loop transfer function 0. So open loop transfer function 0 means 0 location will be S equal to minus 5. So
minus 5.
so you have three poles but 1 0. Then how your root locus diagram will be complete? So to complete the
So
root locus, yeah,
between 0 and minus 2, we'll have one breakaway point, sir.
no, not that is not my question. I am not coming to that till now. Just I am just in the basic part that you have three poles, okay, but you have only 1 0. You know that in any question you first see how many poles are there. Here in this case, poles, a number of poles are greater than number of 0. So it means the number of root locus branches will be always be equal to either number of poles or number of zeros, which is greater. In this case, poles are greater than 0. It means 3 poles, 1 0 is there. So number of root locus branches, this should be equal to number of poles. Suppose in this example, number of zeros will be 3
3. 3.
and number of poles will be 1. Then how many root locus branches will be there? Reverse case I'm saying. You suppose number of 0 is 3, number of poles will be 1.
3.
Then still 3. So root locus,
3, sir.
right. Root locus number of branches will be equal to either the number of poles or the number of 0, which is greater. So here in this case, number of poles will be 3. So definitely 3 branches will be there. So just just a minute. Let me take a paper here. Okay. So in this equation, number of poles is greater than number of 0, which is 3 greater than 1. So it means the number of root locus branches equal to 3. So remember that a root locus of suppose there are 3 poles. I'm just drawing 3 poles. And there are somewhere 1 0 is there. Let's make this is 0. So you are saying that the number of root locus branches will be equal to 3. It means suppose one pole is starting from here and it will end here at 0, because you know that the root locus diagram will be start at open loop transfer function pole and it will end at open loop transfer function 0. So whenever one pole will meet a 0, then one root locus diagram will be complete. So I can say that this portion is called a root locus diagram. But remaining other two poles are there. So how they will move and where they will reach? That is my question. So where they will end? It has to be end on open loop transfer function 0. But open loop transfer function 0 are only 1. But closed loop transfer, there two steel poles are there. So where they will end? Are you getting my point? My question you are understanding? I am saying that whenever a pole will meet a 0, then the root locus diagram is complete. So one pole, let's say it meets a 0, so one root locus diagram is complete. But another two poles are there, but there is no 0 is there. Then how they will meet? At which point they will meet?
So they will meet at breaking
No,
breakaway,
they will meet at the breakpoints, but
and from there they will go to infinity, sir.
yeah, that's the answer. Okay, so it means remember that whenever there is no root locus zeros are there, it means these two closed loop poles, these two poles will be meet at 0 at infinity, somewhere at infinity. I don't know on which path they will go, but they will meet at infinity, and at which direction they will move and reach the infinity decided by the angle of asymptotes. Okay, so that will come to later, that part. But now, so in this question, in the first question, so the answer is 3, right? So how
Yes,
many
sir.
branches to the root? Right, the answer should be 3.
Sir, small doubt, sir.
Yeah, sure.
Sir, how this open loop transfer function poles will be 0, sir? That ds is equal to 0, sir.
Which one? This one?
This last open loop transfer poles implies ds should be 0, means that g of h is equal to 0, sir. We have to make.
No, no, no. In suppose a transfer function is given, how you are finding out the poles? Poles means you are equating the
Okay,
denominator
0.
equal to 0, right?
Okay, sir. Okay, okay, right, sir. Right. Got it.
Yeah, for finding out the zeros, you will equate the numerator equal to 0. That's I'm doing here.
Okay, sir. Okay, sir. Okay.
Exactly. Yeah, actually, you got my points. See, I am not finding out the root locus in the general procedure and lots of rules. I will just give you some shortcuts. Okay, how will you find out? How will you quickly able to find out the root locus? Okay, hardly maximum 1 minute to 2 minutes you can solve any question. Okay, so let me go step by step so that you will understand and there will be no further doubt. So now you understand that your root locus diagram will start at open loop pole and will end at open loop 0. Okay, so whenever there will be number of poles will be more than number of 0, remember that in control system is always a low pass filter. Low pass filter means the number of poles are always greater than number of 0. Okay, it just remember, you'll never find a case when the number of zeros will be more than number of poles in control system in practical application. Okay. So now come to the second point is that, then so let me give an example. I'm just drawing by myself. Let's say this is a pole at s equal to 0 and this is s at s equal to -1. This is s equal to -2 and this is s equal to -3. Now tell me which person is lies in the root locus diagram from this. Forget about question number 2. Let's put a question like this. I'm just drawing a root locus pole location only. If you want a 0, then you can put a 0 at s equal to -4. Okay. Now tell me, and from -4 to infinity, minus infinity, nothing is there. So now tell me, there are one section, section 1, section 2, section 3, section 4, and section 5. So out of this 5 section, which section will be lies in the root locus diagram? Can anybody tell me?
So
Section 1 lies in
1,
the
3, and 5.
1,
Right.
3, and 5.
So what principle you are applying, what rule you are applying? Number of poles and zeros to the right of that equal to odd, right?
Sir.
Yes, sir.
It's fine. Uh, you know the rules a bit better. Now, suppose I am doing like that. Now you can tell 1, 2, 3, 4, 5.
Same applies, sir, because
Fine, right. So you are on the same page now. So now, first of all, why this rule is coming? So this rule is there. Now, by using this rule, one condition is you have to satisfy. So what is that condition is called the angle condition. Have you aware about that? What is angle condition? Angle condition 1, second condition is magnitude condition. Do you know these two rules?
No, sir.
Yes, sir.
yes, sir.
Okay, let me give some. Suppose somebody don't know how this condition will come. You know that root locus is nothing but you have to convert a open loop transfer function into closed loop transfer function. Let me gh is an open loop transfer function. You are finding out the closed loop transfer function by using 1 plus gs equal to 0. Let me someone wants to join. Fine. Okay, so now to satisfy what is the angle condition? Angle condition is that again what you are going to do, this whatever the characteristic equation is there, this is a closed loop transfer function pole, you again convert into open loop transfer function. Why? Because we are using open loop transfer function to find out the root locus. That's why I'm converting this transfer function, the equation 1, into again open loop transfer function, which is nothing but -1 plus j0. Let's say I can represent like this, -1 plus j0. So from this, what is the angle of GS? GS angle equal to nothing but some 180 degree, because it is lies on this point. Okay, -180 means this point. But whenever you are coming to this point, again you will get some 0 degree, then it is again 180 degree, then here it is again 360 again. So these 0, 360, these are even multiples of 180, and 180 is nothing but odd multiples of 180. So whenever you will encounter this -1 point, you will always come with odd multiples of 180. So I am writing it as some odd number 2q plus 1. So let's me plus minus I am giving, whether if you are moving on this axis clockwise, you will encounter plus 180. If suppose some person will be by mistakenly moving anti-clockwise, he will encounter minus 180. So in both the cases will be satisfied. So it means when GS HS equal to -1 plus J0, so if you will finding out the angle of that transfer function, it will gives some odd multiples of 180. And what is the magnitude of this GH? That is equal to 1. Right? So this is called your angle condition. This is called your magnitude condition. So first of all, why angle condition is required? Why you require angle condition?
So it is used for angle of asymptotes.
No, not angle of asymptotes. First of all, why you require angle? Angle condition is required because suppose in any suppose a open loop transfer function is given to you. Let me give an example. Okay, otherwise you cannot able to understand. Forget about this question. Okay, I will come back to this question later. Let me give an example. Let me give an example of angle condition. Okay, why angle condition is required? So let's say GH is given by some k divided by s into s plus 2, let's say s plus 4. So this transfer function is given to you. I'm asking you that I'm giving 2 points, s equal to -1 and s equal to -3. Okay, there are 2 points is given. So whenever you see this question, you know that this is at s equal to 0, somewhere it is equal to -2, and here it is equal to -4. So we can say that this location lies in the root locus diagram. This does not lie, and from -4 to -infinity, this again lies in the root locus diagram. So this is a first point you inspect, that which portion is lies in the root locus diagram, which is not lies in the root locus diagram. Are you clear my point? Yes or no?
Yes, sir.
Yes,
So
sir.
but
Yes.
I'm asking you, a is equal to -1. Suppose a complex number I will give, a is equal to -1, but simply a is equal to -1. Then you have to put this a is equal to -1 here, and you can see that in between a is equal to 0 and a is equal to -2, a is equal to -1 is lies. So your answer is that a is equal to -1 is lies in the root locus diagram. Similarly, again, a is equal to -3. By looking at this diagram, you can say that a is equal to -3 not lies in my root locus diagram. Okay, but this you can again verify by using angle condition. Angle condition how? So suppose this, because why you are using this? Because sometimes I'm giving an example. Let's say hmm, because this is a simple example. Let me give a complex. Okay, is equal to k divided by s into s plus 4. Okay, now my point is that you have to find out a is equal to -2 plus j2. Now you can tell me whether this lies in the root locus diagram or not. How can you tell that? Whether this point lies in the root locus or not. So you know these rules that okay, this a is equal to 0, 1 pole is there, a is equal to -4, 1 pole is there. But I have no idea about that -2 plus j2 somewhere here, whether it will be lies in the root locus or not. Then what you do in that case, you have to use your angle condition. Angle condition means, angle condition will give you that in a root locus diagram, whether a point will be lies on the root locus diagram or not. So what you will do, just simply put k equal to minus 2 plus j2 in the pole location. So again minus plus j2 plus 4. Okay, just to find out what is the angle of this part and what is the angle of this part. If you use your calculator, you will give a value of something 2.82 and the magnitude and at an angle of 135 degree. And for this second part, minus 2 plus j2 plus 4, which is nothing but 2 plus j2, and you'll find a magnitude of how much. Let me give an example. Yeah, you'll get again 2.82 at an angle of 45 degree. Now if you find out exactly what is the value, so it will be 2.82 and 2.8 should be multiplied and will gives you k by 8 at an angle of, so these two angle will be add off. Now it will gives you 180 degree. Now when this term 180 will be go on the numerator, it will be k divided by 8 at an angle of minus 180. Now it satisfies, it means this point will satisfy the angle condition. Angle condition means, so the angle should be any odd multiple of 180. So it is odd multiple of 180. It means this point is lies in the root locus. Are you following?
Yes, sir.
Now
Yes, sir.
after that, why magnitude condition is required? So magnitude condition is nothing but I told you gs equal to minus 1 plus j0 and the magnitude equal to, you find out the magnitude of this equal to 1. It means magnitude condition, if you equate this transfer function after what you finding out, so k divided by 8 into minus 180, if you equate the magnitude part, what is the magnitude part? K by 8. So if you equate the magnitude part equal to 1, so you will get k equal to 8. It means the magnitude condition is required to find out the system gain. Understand why magnitude condition is required and why angle condition is required. Angle condition is required whether to know a system pole lies on the root locus or not, and magnitude condition is required if that point lies on the root locus, then at that point what is the system gain. So you find out. Are you following?
Yes, sir.
Yes, sir.
Now let's come to um, now let's come to question number 2. Okay, let's come to my second part. What is centroid? So what is the answer of this one? Let me zoom it and put here question number 2. So what is the centroid of this one? This is question number 2. So first of all, you understand that why centroid is required and when centroid is not required. So when you require centroid,
When the poles are more than
yes, more than.
0, sir, then only.
Uh, any other guess? Just you're guessing it, then okay.
Sir, centroid minus 3.6.
No, I'm not asking you the answer. I'm just asking you is that when you require centroid, when at which point you are required to find out the centroid, and when you don't require a centroid. Okay, centroid is something summation of real part of poles minus summation of real part of 0 divided by number of poles minus number of 0. This is the formula. Okay, you can find out the answer. That doesn't bother to me, but why you require a centroid, and when you does, is the centroid always lies on the real axis or it is somewhere else, means it can be on the imaginary axis. That's my question now.
Sir, if number of poles and number of zeros are equal, then you can't find centroid, sir, because
Right, so for finding out the centroid, number of poles should be greater than or equal to number of zero, right?
yes, sir.
And again, is the centroid lies on the real axis or it will be somewhere else except real axis? Or my second question is that first, one by one will go whether the real centroid should be lies on the real axis or not. Centroid should always lies on the real axis. Third point, that is the centroid lies on the root locus diagram, or means root locus diagram means I already told you that which section lies in the root locus diagram. So whether I'm asking you that centroid, it can be in the root locus diagram or it can be somewhere which is not a part of the root locus diagram.
It is part of root locus, sir, because where asymptotes meet.
Yeah, no, it's absolutely not, sir. See,
Sir,
centroid
it
can be,
may or may not, depending upon the
the
sum set.
centroid can be anywhere, okay? But anywhere means it can be lies on the root locus. It doesn't lies on the root locus, okay? So it does not necessarily it always lies in the root locus. And the purpose of centroid is that you have to find out the angle of asymptote, okay? So in this question, the centroid of the asymptote is located on the real axis. At which point, find out, no problem. So let me give an example. So for let me give an example. GH equal
Sir,
to,
small doubt, sir. When centroid required and when not required, you are not told, sir.
already
You
told that
asked
na,
us.
when number of poles will be greater than 0, then
Okay,
it
okay.
required to find out a centroid, okay?
Okay, sir. Okay, okay.
So let me give an example. I'll give some question. I'll also certainly solve some question where it doesn't require a centroid to find out, okay? Let me give an example like this: s plus 2 into s plus 4. Next, tell me what are the angle of asymptotes? What are the angle of asymptotes?
So 0, 180 and 330.
0, 180 and 330. Angle of asymptotes, sir. What is the angle of asymptote formula?
2q plus 1 into 180 by
2q
p
plus 1
minus.
p minus z, sir.
Yeah, P minus Z, na? So here, so don't use this formula. So what you do here, just remember that always what to do, first of all, 180, okay, because in the numerator you know that it is an odd multiple of 180 divided by number of poles minus 0. So number of poles minus 0 is 3. So 60 degree, okay. So the first angle of asymptote is 60 degree. Then take odd multiples. Odd multiples means let again 60 into again odd multiples how much? Into 3. 180 and again 60 into 5, 300. Because number of asymptotes, you know, number of poles minus 0. So number of poles minus 0 is 3. So 3 asymptotes and the angle of asymptote is 60, 180 and 300. Okay, if you also put in the formula 2k plus minus 180 divided by p minus z, if you put k equal to 0, then k equal to 1, then k equal to 2, you will get this one. So what you do, just 180 divided by number of poles minus 0, you see. So number of poles minus 0 is 3. So divide first 60 and take the odd multiples. How many you have to take? 3 you have to take, because number of poles minus 0 equal to 3. That's why 1 time, 2 time, 3 times. So these are the angle of asymptotes. So what will you do? So first to draw the root locus diagram. So this is s equal to 0, s equal to minus 2, s equal to minus 4. So you know that This is the root locus diagram. This doesn't belongs to root locus diagram. Again, this part is lies in the root locus diagram. So the middle part is doesn't lie. Then you find out the centroid. Centroid is nothing but summation of real part of poles minus summation of real part of 0 divided by p minus j. So I'm saying minus 4 minus 2, the minus 6 divided by 3 is minus 2. So this minus 2 is nothing but my centroid. And at this centroid, you have to draw your angle of asymptotes. So one will go at 60-degree angle, another will go at 180-degree, another will go at 300. Like so, this pole. So one pole will be move in this direction to reach at infinity. So another pole will be go in this direction, and it will reach at infinity to 0. And other two poles will be okay, and this pole and another pole will be go somewhere and to meet the 0. Okay, I don't know where it will go, but and sorry, another pole will go in the 180 direction, 180 direction to reach the 0 at infinity. So these are the three poles. Look, means pole movement. So one pole will be reaches at infinity here, another will be reaches at infinity here, another will be reaches at infinity here. Are you getting my point? How your pole should be moved?
Sir, please explain, sir. This diagram.
You did not follow?
Yes, sir. Sir, good night, sir. Up to this point, okay, sir. How you had drawn this root locus?
Okay. Be listen carefully, okay, what I'm going to suppose this question is given to you and how you will draw the root locus diagram. There are four options with you. So what you do, if I'm with you, then suppose I'm in your place, then I will start this question. So first of all, I'll look at my pole location. This is s equal to 0, this is s equal to minus 2, this is s equal to minus 4. You know that which are your root locus part. So from s equal to 0 and s equal to minus 2, there exists a root locus branch, right? From again, this part, this does not belong to root locus. From again minus infinity, minus 4 to minus infinity, again whatever this path is, it belongs to a root locus diagram. So which are belongs to root locus diagram, I am denoting by red lines, okay? And which does not belong to the root locus diagram, I am just black lines. Up to this, you are clear?
Clear, sir. Up to that, okay, okay, sir.
Second point, you need to find out the centroid, okay? Because number of poles are greater than number of 0, so you require a centroid. So centroid is nothing but is gained by summation of real part of poles. So real part is minus 2 minus 4, so it will be minus 6. No 0 is there, so 0 is 0. Divided by number of poles minus 0. Number of poles is 3, number of 0 is 0, so 3, so that will give you minus 2. It means this minus 2 is nothing but my centroid, right?
Okay, sir.
Right, sir. So what is the purpose of centroid? Centroid is required to find out the asymptote angles, okay? So I told you that these are the asymptote angle. One is 60 degree, another is 180, another 300. So at this centroid, you make an angle of 60 degree. At this centroid, you make an angle of 180 degree. 180 degree means it will be on the negative real axis. Another is 300 degree. So these are the three asymptotes, right? Clear?
Okay, sir. Okay.
Why asymptotes are required? Because you know that here number of poles equal to 3, number of zeros equal to 0. It means, remember, a root locus diagram will be complete when a pole will reaches the 0. So you can see that. So suppose these poles will be starting here because this is a root locus path. I'm just changing my color. So let's say this pole is coming in this direction. Another pole will be coming in this direction. And at this centroid, suppose let exist this breakpoint, they will be collide, and these two pole will be moved in this direction because they have to be traveled in the direction of asymptote to reach the 0 at infinity. Again, and another pole will be, it will go in this direction to reach the 0 at infinity. Again, there are three poles, so two pole already got. So let's say this point, this pole is again going in the negative direction because this is asymptote direction, and it will reach the infinity at somewhere at infinity, and it will reaches the 0, and 0 you assume that it is placed at the infinity. So this is your three directions at which your poles will move and reaches the 0 at infinity. You Getting my point? So this is a root locus diagram, complete root locus diagram.
Okay, sir. Okay, sir. Thank you.
Okay, so it not exactly the same direction. Maybe and the breakpoint suppose here, then these two poles will come and they will move parallel to the asymptotes. Okay, the root locus can be parallel to the asymptote. It need not exactly in the root locus, means need not exactly follow, but remember that the root locus diagram are always parallel to the asymptotes. Okay, it need not be exactly in the asymptotes, but will follow. Let's say this breakpoint is somewhere not here, it will be somewhere in the middle, then definitely this pole will be approach. You are coming, I am coming, I will collide, and I have to go and break here, and I will follow this asymptote line parallelly, and I'm reaching infinity. You got my point?
Yes, sir.
Yeah. So this is the case. Okay. Let me give an example. An example. So before coming to this question number 2 is over. Before coming, okay, just need to, okay, what is breakpoint? Okay, let me give here. What is breakpoints? Can anybody tell me breakpoints? How can you find out breakpoint? How do you find out breakpoints?
First characteristic equation, sir.
Yeah, suppose the characteristic equation is like that. Then,
So represent K in terms of S, sir.
right. Let's say k divide k into g of h, like that. I'm saying let play 1 plus k gh equal to 0, then gh equal to minus 1 by k. Then what you do?
So dk by ds
dk
is
by
equal to
ds
0.
equal to 0 and find out
The S value, sir.
s value. This gives you the
So
breakpoint, right?
that we need to again
Put in the k
substitute
value
that if it is
positive, then
then
that is a
only
breakpoint,
breakaway point, otherwise it is not a breakaway point.
right? Everybody follows that. This is in the lecture, okay? So what you do? So don't find the characteristic equation. So what you do? Let me give an example. Let me give an example. Gs equal to k divided by s into s plus 2. So find out the breakpoints. You can quickly tell me, just in 1 minute, and tell me the answers, okay? Everybody, please. So k divided by s into s plus 2. Put gs equal to minus 1. Find out k. K is nothing but s into s plus 2. dk by ds equal to 0. So minus s square. So minus 2s minus 2s. So minus 2 equal to 0. So s equal to minus 1. Right? Everyone got s equal to minus 1?
Yes, sir.
So this is a breakpoint. So after solving, you can confirm that s equal to minus 1 is a breakpoint. Then you need to put this s equal to minus 1 here. Okay. Put a equal to minus 1 into minus 1 plus 2 equal to minus 1. So we are getting k into minus 1 into 1, which is minus 1. So k you are getting 1. So k is positive. That's why you are confirming that this is a breakpoint. Clear, everyone?
Yes, sir.
Okay. I'm giving a second question. K divided by s into s plus 2 into s plus 4. Find out the breakpoints. Again, what you do? This is GSHS, right? This is GSHS is given to you. So again, what you put, k divided by s into s plus 2 into s plus 4 equal to minus 1. In place of GSHS, you put minus 1. Then equate k equal to minus s into s plus 2 into s plus 4. And you solve this quadratic equation, dk by ds equal to 0. So I'm giving you the answers, okay? The points I'm giving you to. Don't solve it. I'm just giving you the answer. 0.845. This is the first S1. Then another S2 will giving you minus 3.154. Then another S3 is giving you 0. So these are the poles location. Now can anybody tell me which are the valid breakpoints, which are not the valid breakpoints? You have to put this S1 here first, then find out K value. You are putting S2 here, then find out K value. You put here and find out K values. First you need to verify with S equal to 0. So this is, sorry, S3 not will come because S2 will come.
Sir, S1 equals to minus 0.845.
Is a root locus, right? Because for this K equal to positive, sir, right?
Yes, sir.
And for minus 3.154, it is negative.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So, but can anybody tell me out of these two, which are whether it is a break-in point or breakaway point? You know that this is break point, but break point can be either break-in point or breakaway point. So, which one is break-in point? Which one is breakaway point? How can you ensure that? You are saying that this is not a break point, but this is a break point. But I'm asking you whether it is a break-in point or breakaway point,
Sir, if we have in between two poles, I'll have breakaway, no, sir. In between two zeros, I'll have break in.
right? Exactly, right? So remember these three thumb rules, okay? Because if you know these 2 3 rules, then you need not solve all this question. No need to solve, because in the examination they will not ask you the exactly how the root locus diagram. They will ask the exact shape of the root locus diagram. Okay, shape is matter. Shape matters rather than the exact point. So so remember that whenever there are two poles are there, and in this and there exist a root locus branches between the two poles, then definitely there is a breakaway point. Okay. Similarly, when there are two zeros are close to each other and there exists a root locus branch in between them, then definitely there is a break-in point. And this is most important, the third one. The third one is that whenever a zero is there, remember that whenever a zero is there, and to the left of that zero, there exists a root locus branch, okay, up to infinity. There exists a root locus branch up to infinity. Then there is a break-in point. The condition is that the number of poles should be greater than or equal to the number of zero. This third case, you got my point. Whenever a zero is there, and to the left of that zero, a root locus branch is there up to infinity. So there must be a break-in point if the condition is that the number of poles is greater than number of zero. Clear the third one?
Yes, sir.
But the reverse you can also ask me, sir. Why? What is the reverse condition? If there is a zero, if there is a pole, and to the left of that pole, there exists a root locus branch up to infinity, there exists a breakaway point if the number of poles is less than number of zero. The fourth point also clear.
Yes, sir.
But this condition, remember the fourth condition, you will never find in any question. You will never find in any question this condition, because remember that I told you control system is a low pass filter, and always the number of poles should be greater than equal to number of 0. So this condition it violates. Okay, so number of zeros can never be equal to number of poles in any system. So this condition hardly you encounter. If somebody intentionally gave you some questions, then you remember that this rule is applicable. But you will never find in any question which will come into the fourth category. Now coming back with our questions, okay. The first question I ask you, find out the breakpoint here. So what you do, first draw the root locus diagram here at a is equal to 0 and a is equal to -2. So you know that from a is equal to 0 to a is equal to -2, there exists a root locus branch, okay, because uh, the sum of poles and zeros at this point is odd. So from a is equal to 0, a is equal to -2, there exists a root locus branch, and definitely there exists a breakaway point, right? Because this satisfies our first condition, right, ma'am?
Yes, sir.
Are you following? Similarly, the second question, if you apply the second question here, then you first draw the root locus diagram. Here a is equal to 0, here a is equal to -2, here a is equal to -4. So which portion is coming into the root locus diagram? So this portion is coming into the root locus diagram, and this portion is coming into the root locus diagram up to infinity. Up to infinity, right? So now you apply the rules. The first rule says that whenever there are two poles, then definitely there is a breakaway point. And here this fourth rule is applicable, but here the fourth rule is not applicable because the number of poles should be less than number of zeros. It is not satisfied in this question. That's why there is no break in point or breakaway point after this line. Clear? The fourth point is not applicable here. So
Yes, sir.
definitely there is only one breakaway point, and that is equal to s equal to -0.854, which is lies between s equal to 0 to s equal to -4. So -3.154. By looking at this diagram, you can say that as this portion is not lies in the root locus, so definitely this -3.154 should not be a breakaway point. This is by inspection. No need to find out and putting back into k equation and tell the answer. You got my point?
Sure, sir.
So in this way, you can find out the breakpoints and breakaway points. Okay. If you clear, then this is my. I'm just giving a typical question. This is breakout point. Let me erase it out. Okay. Now just solve this question. Okay. Let me give gh equal to k into s plus 4 divided by s into s plus 2. Find out the break-in and breakaway point. Question is that find out the break-in point and breakaway point. I simply can find out breakpoints. Okay. What are the breakpoints? Solve this equation, putting gs equal to -1, find out k and dk by ds equal to 0. I'm giving you the poles location. S1 equal to -1.17, S2 equal to -6.82. Okay. Now these are the two poles. Don't solve. Just look at these 2 points and tell me that which point is a break-in point, which is a breakaway point. I am drawing the poles location here. This is s equal to 0. This is s equal to somewhere -2, and this is 0, which is s equal to -4. So first of all, you identify which is belongs to a root locus diagram. So this person belongs to a root locus diagram, and whatever the points that is from 0 to up to -infinity, this is also a root locus diagram. Now tell me, -1.17, it will be lies somewhere here, right?
Yes, sir.
So it is a break away point, right?
Hmm.
Because two
Away.
poles. Another point is -6.82. -6.82 is lies somewhere here, and it should be satisfy our property 3, right? It's satisfying the property 3. Whenever there is a 0 is there, and to the left of that 0 there exists a root locus branch up to infinity, so definitely there is a breaking point if the number of poles are greater than number of zeros. So here number of poles is 2, number of zeros is 1, so 2 greater than 1, so it satisfies, so it is a break in point, right?
Yes, sir.
Yes, sir.
So so by solving this you can directly say which is a breaking point, which is a breakout point, like that. Okay, so no need to put back into the k and find out. This will time conversion, don't do that in the examinations. Got my point? Shall
Yes,
I
thank
move?
you.
And
Yes, sir.
next, question number 4. Okay, question number 4. What is how to solve question number 4? The root locus crosses the j omega axis at which point? So first let me go to that question. Which question is talking about? Question number 3. Where is question number 3? Okay, it is talking about this question. Question 2, 3, 4, I think they are linked question. So for that question, he is asking us that to find out the k value at which it will cross the imaginary axis. So actually my slides are like either udhar, but you have to organization. Okay, no problem.
We need to find marginal value of k.
Just me explain the concept. Okay, so first
We
concept is the
need to
intersection
route
point of
table, sir.
imaginary, right? Sorry.
We need to find route table, sir.
Yeah, you need to find out route table. That's your. Let me give an example to find out the intersection of the imaginary axis. Let me give an example. I'm giving you the back example which I have taken s into s plus 2 into s plus 4. For this GH, I have already drawn the root locus. You know that the root locus. Can you find out the root locus? I'm doing it fast. Okay. So this is my pole location s equal to 0. So somewhere it is equal to minus 2. Somewhere it equal to minus 4. Let me connect my charger. Okay, these are the 3 pole location, and I told you. Can anybody tell me what is the centroid of this one? Centroid is minus 2, right?
Yes, sir.
Yes, sir.
And
Sir.
asymptote angles are 60. One is 180, another is 300, right? I already done this question.
300.
Now
Yes,
tell
sir.
me
Yes,
what is
sir.
the break point? Can anybody tell me what is the break points? What is the break point?
0.845.
dk by ds, you solve and tell me what is the break point. 0.845, right, ma'am? Already have solved this
Yes, sir.
question.
Yes,
So
sir. I
give me
told sir 0.8.
right 0.845. So what is your observation? This is the break point means how you will draw the now the root locus. I am telling you. Just let me change my pen. So now you observe that these are the 2 poles here. So these poles will now come closer here. They are approaching. These poles also approaching. At this point, there is a breakaway point because we satisfy a breakaway point. So at this point, they will one pole will go parallel to the asymptote like that, and another point here. These poles will come here and it will parallel to the asymptote, and it reaches at infinity at 0, and the other poles here which is placed at s equal to minus 4 because this region is not belong to root locus, not in the root locus diagram. But after this point minus 4 up to infinity, this is the root locus diagram. So this 4 minus 4 will come here, it will come like that, and it reaches at minus infinity and approaches the 0. So this is the pole location. I am drawing the pole location by the arrow, and this is your root locus diagram, complete root locus diagram. But the question is that whenever this pole is coming, it will marches this imaginary axis at some point. So what is the point? That is the question here. So you have to solve the RH criterion to find out the marginal stable, because this root locus branches whenever reaches and touches the imaginary axis, then the system will be marginally stable. So at marginally stable, this is third order system. I told you for third order system how to find out the marginally stable. How to find out the marginally stable? Find first of all, find out the characteristic equation. SQ plus, find out. This will be, what is the characteristic equation? S square plus 2s into s plus 4, that is nothing but s cube plus 2s square, 4s square is 6x square plus 4 to 8s plus k. This is the characteristic equation. Everybody clear?
Yes, sir.
Yes,
So
sir.
I told you that how to find out the marginally stable, because the inner product should be greater than equal to the outer product. So inner product is 48, outer product is k. So k should be equal to 48. So in this equation, you put k equal to 48. After putting k equal to 48, how to find out omega value? I told you that equate the which term equal to 0? The even terms equal to 0, right? So 6x square, 6s square plus 48 equal to 0. So solve this equation, find out s equal to plus minus j root 8, right? Are you getting the point?
Yes, sir. Yes, sir.
So here this point is j root 8 and this point is minus j root 8. So these are the location at which this root locus will be touch the imaginary axis. Any doubt till now? This is the last class. I just making it faster because you know how to find out the oscillation, means omega value. Everyone is clear?
Yes, sir.
So in
Yes,
this way
sir.
you have to find, yeah.
Sir, what is the question asked, sir? Where the complex
No,
root
at
is?
which point this root locus diagram will be crosses the imaginary axis,
Okay, sir.
because you are seeing now this root locus branch, some point it will cross the imaginary axis, because this is the
Okay, sir.
exact root locus diagram I am drawing. So at which point it will touch, at which point it will cross the imaginary axis, at that point it should be marginally stable. So you know the
Okay,
condition
sir.
of marginally stable and finding out k and the exact location.
Yes, sir. Yes, sir. That is that done in Rotharwitz.
Yeah, can use by RH criterion with a fourth order system. Then use by RH criterion. If it's not a fourth order system, then simply apply the third order system property and answer it very less time. Everyone is clear?
Yes, sir.
Now, this is the angle of departure and angle of arrival. So I think this part is also covered in this week, fifth. Okay. So how do you find out the angle of departure and angle of arrival? What is the angle of, how to find out the angle of departure? Can anyone tell me the formula?
Sir, pi d is equal to 180 minus pi, sir. Angle of departure is 180 minus pi, where pi is
Phi is
sum
what?
of
Sum of real part of
real part.
contributed by poles minus sum of angle contributed by 0, right?
Yes, sir. Yes, sir.
So don't do this, don't use that formula from now onwards. So what do you do? Let me give an example and so I will solve it. Okay. Let me give a question. This question is given by a into s plus 2 into s plus 4 and divided by a square plus 2s plus 2. So remember that angle of departure and angle of arrival is always calculated at a complex pole. If poles are complex, then you need to find out. If poles are not complex, then no need to find out angle of departure and angle of arrival. So don't waste your time by calculating angle of departure and angle of arrival. So first see, so this is a pole s square plus 2s plus 2. You find out the roots, then definitely these roots are complex. So you need to find out the angle of departure and angle of arrival, right? Are you getting my point, sir?
Yes, sir. If and only if the roots are imaginary, then only.
Then you need to find out the angle of departure and angle of arrival.
Otherwise, no need to find
No
out,
need to
sir.
find out, sir. No need to find out. Okay. So s square plus 2s plus 2 equal to 0. Can anybody tell me what are the pole location? S1 and S2?
-1 plus or minus j, sir.
J1, right? So
Yes,
this
sir.
is this is your step you have to do. So I'm telling you to how you will find out the angle of arrival and angle of departure directly. So what you do, you take the denominator equal to 0 and find out these roots. Okay, remember that roots are right somewhere in the paper. I have written like this. So what you do, the next step what you do, you just like write down s plus 2 into s plus 4. See this s square plus 2s plus 2, can I write like that, s minus s1 into s minus s2, because this is a second order equation and s1 is nothing but here s1 and s2. Can I write like that?
Yes, sir.
Couldn't, sir.
So I'm just writing down. Okay, so here I'm writing s minus s plus this is minus 1 plus j1. So one pole will be like that, other pole will be like that, plus 1 plus j1.
1 plus J.
Okay, so this is your second step. Then what you do, ma'am, take the positive pole. What is the positive pole? Minus 1 plus j1. Okay, this pole you put everywhere. You pull at all the s points. So I'm putting here minus 1 plus j1 plus 2, minus 1 plus j1 plus 4, and if I put here minus 1 plus j1 minus plus 1 minus j1 minus 1 plus j1 plus 1 plus j1, just I put the positive pole, whatever there are two poles here, positive pole, negative pole. So take the positive pole and put every s point and just find out the angle. No need to find out the magnitude. I don't require any magnitude. Just find out the angle of each term. This is the first term, this is the second term, this is the third term, this is the fourth term. Just find out the angle. So what is the angle of the first term? I'm writing in the here. So k into, so this will be 2 minus 1 is 1 plus j1, so 45, right?
Yes, sir.
What is the angle of this one, ma'am? 3 plus j1. What is the angle of this one? 3 plus j1. Some
So
18.48.
44.
I'm writing 18.48. Whatever, I'm just calculating the angle, ma'am, right? Then here j1 and j1 cancel, this get cancelled, so this angle will be 0. And here what is the angle? Minus 1, 1 get cancelled. So j1 plus j1 is j2. So this angle is 90 degree, ma'am, right?
90 degree.
So what is the overall angle? Just tell me what is the overall angle, ma'am. 45 plus 18.48 minus 90. Are you with me? This is the overall angle.
Yes, sir.
What is the angle, sir? Tell me. Minus 26 point something, right, sir?
Yes. Yes, sir.
So this is your angle phi, and so what you do, the angle of departure is nothing but 180 plus this angle. 180 plus this angle, ma'am. So 180 plus minus 26.57. So whatever the angle, that will be 153.43. This is your angle of departure. Are you following me? How I calculated angle of departure? This is the simplest process, okay? Otherwise, what you do at every point, you need to find out the pole's angle or add it. At every other points, you need to find out the angle of all the zero, then you add it, subtract it. Then again, you have to subtract it from 180. You get confused in the examination. So simple. So first question in your mind, that why I told you this is angle of departure, why not angle of arrival? Because this is a complex pole. Remember, for complex pole, I required angle of departure. If it is a complex zero, then I required angle of arrival. Same way. No, don't change your way. For angle of departure, you find out the angle like this and add 180. For angle of arrival, from 180 you subtract that values. This is the only difference.
Sir, please explain the last point, sir.
Which point,
Okay,
Up
ma'am?
sir.
to up to minus the angle up to pi, it's clear, sir. Minus 26.57. After that, how do we get pi d, sir?
After getting this angle you got, sir, minus
Yes, sir. Yes,
26.57.
sir. Okay,
After
sir. After
that,
that, clear, sir.
in your mind, you have to feed that whether I require to find out angle of departure or I require angle of arrival. So
Okay,
look at the question. See whether the complex pole is there or complex zero is there.
complex pole is there, sir.
Whenever you see that complex pole is there, then you need to find out the angle of departure.
Okay, sir. Okay.
Whenever you require angle of departure, add that angle into 180. You will get the angle of
Oh,
departure. If suppose,
okay.
just reverse the question, a square plus 2s plus 2 in the numerator now.
Okay, sir. Okay.
Then
Then
in
it is
that
the
case,
angle
that is the
of.
angle of arrival. So what you
Okay, sir.
do,
Then.
that angle you just subtract from 180. Here you add, in angle of arrival you just subtract. This minus
Okay, sir.
26.57. From 180 you subtract. In angle of arrival you remember 180 minus. In angle of departure you remember 180 plus.
Is there any region, sir?
It's not not any region, sir. It's just a way of means getting the
Okay, sir.
answer.
Okay. Okay.
It's clear my point, everyone. You check, okay? You check any question. Okay. I think question number 5. There is something. Otherwise, this is the question number. This in this question number 2, where I'm writing k divided by s into s plus 5 a square plus cx plus 17.6. See, there is a square plus cx plus 6s plus 17.76, right, sir?
Yes, sir. Yes.
So this is a complex pole, right?
Yes, sir.
So find out the positive complex pole. Don't take the negative complex pole, sir. Take the positive complex pole and put everywhere. Find out the angle. You require an angle of departure here because you require a complex pole, and 180 plus that angle, you find out the angle of departure. So solving this question, in that question also, if you go to the here, it is asking in question number 5, what is the angle of departure for that complex pole. Are you getting? So you can find out.
Okay, sir. Okay, sir. Okay.
So I am not
Sure,
solving
sir.
any question, just I am giving you the approach how I will solve the examination. Uh, let me give an what is the time? Just me. Okay, half an hour is there. Good. So let me give an example. In this example, I'll clearly define everything. Just listen from starting to ending how I am solving questions. Okay. Let me go through this question. Let GS equal to, your root locus will be completely clear by solving another 2-3 question. Okay. So s into s plus 2. This is a simple question I am putting in front of you. Now I am asking you to find out how I'm solving this question. Okay, so let's see. Suppose this question is in front with me. So how I solve this? Let's see. You just observe, wherever doubt, you just stop me. So first find out the pole location. S equal to 2, 0 and s equal to minus 2. These are my two pole location. This is the first point. Find out the pole location. Second point, you have to find out which person is lies in the root locus and which person doesn't lie in the root locus. Let's change my color. So definitely I can see that this person is lies in the root locus, and the rest part up to minus infinity, it doesn't lie in the root locus. Okay, up to this point is clear, everyone?
Clear, sir.
Yes, sir.
Then you need to, is you required to find out the breakpoint? And if you require to find out the breakpoint, what is that breakpoint? Find out the breakpoint. Summation of the real part of poles, so minus 2, एक जीरो नहीं है, कुछ भी नहीं है, divided by number of poles minus 0 2, so break point is minus 1, right? So look at that break point here. This is the break point minus 1, right, sir?
Yes, sir.
Next point, you need to find out angle of asymptotes. Okay, so first of all, you identify how many asymptotes are there. Two asymptotes are there because number of poles greater than number of 0. So, and what are the angle of asymptotes? One is 180 divided by 2 is 90, and they take the odd multiples, 270. I told you how to find out that. So what you do, always 180 divided by number of poles minus 0. So I'm writing the process. I think would not.
Yes,
First,
sir. Yes, sir.
number of poles minus 0 you find out. Poles minus 0 is 2. Then I told you 180 divided by that, p minus z, that is 2. So 180 by 2 is 90 degree. And because it required two asymptotes, so one asymptote at 90 degree, other is odd multiple. Odd multiples means 270. So at minus 1 point, you just draw that asymptotes 1. Because at break point you need require asymptotes. So I'm drawing that asymptotes here. So this is my asymptotes direction. One is 90 degree, another is 270 degree. So these are my asymptotes. Clear, everyone?
Clear, sir.
Now you require to find out the breakpoints. Tell me what is the breakpoint. If you solve, the breakpoint is also coming at minus 1. So it means these two poles will now start approaching here. It will be come here. This pole also come here. At the breakpoint minus 1, they will collide each other, and this is a breakaway point because two poles are located adjacent to each other, and they will go in the direction of asymptote. So one pole will go in the top, other pole will go in the bottom, and they will reach minus infinity, and it will reach infinity like that, because at infinity 0 is there. So pole will now approaches 0 in parallel to the asymptotes and reaches 0 at infinity. Now everyone is clear.
Yes, sir.
This is the root locus diagram, because you don't require to find out the point at which it crosses the imaginary axis, because asymptote is not crossing the imaginary axis, means no need to find out that part. Also no need to find out the angle of asymptote, angle of departure, because there is no complex pole is there. So last 2% you just eliminate. This is a complete root locus diagram. Now my question, now the real question will start. Now tell me, at which point your poles will be there? At that point k equal to 0, right?
Yes, sir.
So this point poles is there, k equal to 0. And which point it will meet the infinity? And that point, this is k equal to infinity, this is k equal to infinity. This is the definition of root locus, that root locus branch will start at 0. Sorry, start at open loop poles at where k equal to 0, and it will end at open loop 0 at point k equal to infinity. So this is a complete root locus diagram. Now tell me, for which value of k the system is overdamped. This is my first question. Can anybody tell me?
K equal to minus 1, sir.
How can you say, ma'am? Where is minus 1? How can you say k equal to minus 1? See, first you understand, not only ma'am, everyone is following me or not. Up to this, you clear how I draw this root locus diagram?
Sir, small doubt, sir.
Yes.
Yeah.
Without doing anything, how did you get that breakpoint as minus 1, sir, directly?
No, without doing nothing. I am just solve. I solve in, because I have this question is in front of me. I know the answers that I directly written. But
Okay, sir.
otherwise, you have to do solve s into s plus
Okay,
2 equal to minus 1, dk by ds equal to u. You get
okay,
definitely
sir.
at k equal to minus 1.
Okay, sir. Okay. You have written directly. So I thought any
No,
simple
no, no,
process is there.
no, sir. Just these steps you have to do. Okay. So minus 1 is a break point, right? But ma'am, how you're saying that at k equal to minus 1, the system is overdamped? So
Sir,
first of
because
all, no ma'am, first you understand that what do you mean by overdamped? Overdamped means, overdamped means the poles are on the real axis at different location, right ma'am?
yes, sir. Yes.
It means the poles are at real axis at different locations. So now, but your pole is moving. You can see your poles is moving from -2
In
to
all
minus.
negative, sir.
Now you just listen my point now. From -2 to -1, your pole is moving. From s equal to 0 to -1 also your pole is moving, right?
Yes, sir.
Means towards the break point, your poles are moving left and right. But are you know that at -1 point, this break point is -1. At -1 point, do you know what is the k value?
No, sir.
You don't know. You have to first find out, ma'am.
Yes, sir.
What is the, how can you find out? I told you, you have to apply the magnitude condition to find out k at any point, right?
Yes, sir.
So, k divided by s into s plus 2, take the magnitude and equate it to 1. At which point? At which point you want to find out? At -1 point, right?
-1, sir.
So, put s equal to -1. So, -1 and this is -1 plus 2 is 1. Take the magnitude equal to 1. So, you will get k equal to 1, right? It
Sir.
means at this break point, my k value is 1, right?
Yes, sir.
Now you can simply tell at which point, at for what value of k the system is overdamped. I told you the definition of overdamped. Overdamped means my poles are at different location on the real axis.
Real
And
axis. So k equal to 1.
not k equal to 1, ma'am. At k equal to 1, your two poles will be at this point, right? They will be come and close. They will be at this point.
Yes.
They are not on the different location. So it means for, you can see for k equal to 0 to 1, in between k equal to 0 to 1, your poles will be distinct. Getting my point?
Understood, sir. Yes, sir. Understood, sir.
Now from k equal to 0 to 1, the system is overdamped. Everyone is clear?
Sir, please explain, sir.
You are not getting, sir?
Yes, sir.
At which points are you are not getting, tell me? At the definition of overdamped or this root locus diagram? Sir, I told you that. What is the definition of overdamped? Overdamped means a real axis is there and two poles should be different location, right?
Sir.
So it means you can see, sir, from k equal to 0 to 1, in between k equal to 0 to 1, if this pole is moving and reaching at this point, then definitely whatever the pole at here, definitely it will be at somewhere here.
Yes, sir. Yes.
So definitely they are on the real axis. In between k
Yes, sir.
equal to 0 to 1. Because
Yes,
this
sir.
range is k from 0 to 1, right, sir?
Yes, sir. Yes, yes.
So that's why it is overdamped. Now
Okay,
my
sir.
second question, at what point the system is critically damped? So first to understand what is critical damped. Critical damped means the two poles are at the same location, right? Are you following me?
Yes, sir.
So now tell me what is the answer. For what value of k the system is critically damped? सर ये आपको visually दिखना चाहिए कि when these two poles are coming and definitely it will meeting at k equal to which point?
It's -1, sir.
No, sir, this is break point. At break point,
Break
I
point.
already find out the k value. K value is
K is
1.
K1, sir. 1 K1.
So critical damped is k equal to 1, right, sir?
Yes, sir. Yes, sir.
Now you tell me what is for what value of k the system is under damped. So what is the definition of under damped, sir? Under damped means the poles
K
will be
equal to
moved in the imaginary axis. Okay, so you have know that this is the plot. So here if these poles are coming like this coming, and here it reaches and again it moves. So this location is under damped. Okay, under damped means it should be imaginary. but at the negative real axis. So now you tell me, from k equal to 1 to infinity, if I put k equal to 1 to infinity, then my poles will be imaginary. so, so it will be underdamped. Are you getting my points here?
Yes, sir. Yes, sir.
Did you understand the question? The question will be like this, sir. They will never ask a root locus diagram. They will ask from the root locus diagram, how are you imagining that how my poles will be moving in the imaginary plane, and at which point it will be critically damped, and which location it will be under damped, over damped, like that. Are you getting this feel? If you're getting this feel, and I'll solve another question of similar type.
Okay, sir.
Okay.
Okay.
If this question you solve, then definitely you have learned today something. Okay. So let me give this question. K is divided by s square plus 4. First, I'm drawing the root locus for you, sir. Okay. Let me change my color. First, what you do, you look at the pole location. So when 0 is there at origin, right, sir?
Yes, sir.
Another poles are there at -2. Yes, sorry. This should be come here. One is j root 2, another is minus j root. These are the poles. S equal to S equal to. Right, ma'am?
Yes, sir. Correct, sir.
Now, at S equal to 0, means this is 0, means at this point, what is the K value? K equal to infinity, right? At poles, K equal to 0.
Yes, sir. Infinity, sir.
So, whenever you are locating the poles on that side, you write down what is the K value. You know that K varies from 0 to infinity, and K will start at open loop pole and it will end at 0. So at 0, K value should be infinity. At starting pole location, K value should be 0. This is the first observation. Now, second point is that you find out the root locus diagram, breakpoint, and everything. Now you should tell me, first of all, you identify which person is lies in the root locus. So this is a 0 is there. So definitely to the left of that part, all the position are lies in my root locus, because sum of poles and zeros is odd. So definitely this branch up to infinity is a root locus diagram. Clear?
Yes, sir.
Next,
Yes, sir.
third
Clear.
point, you need to find out is breakpoint is required. See,
No, sir.
breakpoint is required whenever the number of minus 0 should be greater than or equal to 2. Okay, this is the condition, remember. So here, number of poles is 2, number of 0 is 1. So it is 1 only, so breakpoint is not required. So I'm not calculating breakpoint. So don't waste your time to find out breakpoints. So breakpoint condition is this one, number of poles minus 0 should be greater than or equal to 2. So don't record breakpoint. Sorry, you record a breakpoint, right? Uh, uh, this is what I'm calculating now. Centroid. Okay, this is centroid condition. So centroid is not required, but breakpoint is required, ma'am. Why? Because apply the third rule. Whenever a 0 is there, and to the left of that 0, there exists a root locus branch up to infinity, there at least one breaking point is there when the number of poles are greater than number of 0. Apply the third rule. Getting my point? Apply the third rule. Third rule saying that whenever a 0 is there on the real axis, and to the left of that 0, there exists a root locus branch up to infinity, then definitely there exists a break-in point. Break-in point. Break-in point. If the condition number of poles are greater than 0. So number of poles are 2, number of 0 is 1. So this condition is satisfied. So definitely here somewhere, I don't know, there exists a break-in point. Right, ma'am?
Yes, sir.
Okay. After you know that, I don't want to exactly find out the location. I don't require. Okay. Suppose you find out, I'm just telling you the answer. The breaking point is at -2. Okay, s equal to -2. If you solve dk by ds equal to 0, the break in point is at -2. I am saying that it is at -2. So you look at that point. This is s equal to -2. This is the breaking point. As you see, there are complex conjugate poles are there. So you need to find out the angle of departure. Right, ma'am?
Yes, sir.
So I am telling you the answer. Don't worry. The angle is given by one is 0 degree. If for this one is 0 degree, and for this one should be, it will be
Pi should be -180.
-1. So for this one it will be 0. So mean this pole will coming in the 0 degree angle, making with, and here it will be -180. So it's starting from here like that. It will come and reaches meet the break point. The pole location are like that. I am just drawing the pole location. This pole is coming like this in this path. This pole making an angle of -180. It is coming and meet at the break point. After meeting at this break point, there are two poles here. So one pole will go and reach the 0 at the origin. Other pole will go in this direction and reach the negative real axis at infinity at the 0. So here k equal to infinity, and here also k equal to infinity. This is the complete root glucose diagram. Are you following me?
Yes, sir.
So after doing that, you need to find out at a is equal to -2. This is a breakpoint. What is the k value? I told you how to find out. Apply a angle condition, magnitude condition. Put a is equal to -2 in this equation and find out the k value. This k value is 4. I am just writing for you that at breakpoint your k value equal to 4. Are you getting my point?
Yes, sir.
Now
Yes,
tell
sir.
me at which value of k the system is overdamped. All the k values I have written for you. Now tell me at which value of k the system is overdamped.
See, sir, for overdamp, it should be in real axis, no,
It
sir.
is the real axis and it is different location.
Yes, sir. But
For what value of k the system will be overdamped. You can see at this point, if one pole will be here, other pole will be here, right?
yes, sir.
Like from the here to here,
Between
when k from
0 to -2.
now from 4 k equal to 4 to infinity, ma'am,
Yes, sir.
the system will be overdamped.
Huh?
Na?
Yeah. K value, no, positive K value.
Yeah,
So I think it is 0 to 4, sir.
ma'am, 0 to 4 means
0
you
less
are
than K
moving.
less than 4.
I'm not getting my point actually. First of all, what is
Sir,
overdamped?
infinity.
Overdamped means your pole
Sir,
should be in the real axis and at different location. So if one pole will be here, other pole should be here. If one pole will be here, if this pole is moving here, then this pole is also moving here. These poles are moving. It means from for 4 equal to
so
k equal to 4 to infinity, this pole is moving in this.
infinity value will come, sir. But how can I say though?
Are you sir following me?
Actually,
Sir,
not, sir.
it
Why you are not following? I don't know. This is the pole location clear, everyone.
is for,
Yes, sir. Up to that point, okay.
Means
yeah, that is okay, sir. For the
this
different
root
okay.
logos diagram is clear to you.
Sir, small
Yeah,
doubt,
that
sir.
also
How
clear,
do you
sir.
get? Uh, I got that doubt, sir. How do you get the angle of departure as 0 and -180, sir?
Sir, I already told you now. You have to find out. You take a positive pole j equal to √2, right?
Okay, sir. Okay, okay.
In that formula, you first put k equal to j root 2.
Okay, sir. Okay,
Okay.
okay.
Then you
Okay, okay.
solve that equation, find out the angle, and add 180 to that.
Okay, sir.
If
Okay, okay.
this
Right,
will
sir.
be 0, definitely other will be minus 180, right, sir?
Right, sir. Right.
Complex conjugates are 180 plus that angle, and this is minus 180 plus that angle, right? Complex conjugates, sir.
Okay, sir.
So after getting that, now this root locus path is clear how these poles are moving.
That is clear, sir.
Now
That is clear, sir.
you are not clear. I'm just listening. I'm just giving an example. Let's see. At j root 2, I am sitting now. Here I am sitting. Okay. And here another person, sir, you are sitting. Okay.
Okay, sir.
And ma'am is sitting at which position? At 0 position, right? Ma'am, you are sitting at 0 position, right? K equal to infinity, right?
Okay, sir.
So now what is happening now? I am now starting moving in this direction because I want to approach a 0. So the angle of departure is saying that you have to make an angle of 0 degree and move. So I'm making an angle 0. I'm moving here in this direction. And by that time,
Mm.
by star is also what is doing, he is also moving at making an angle of minus 180. And simultaneously what is happening at one point of time, we both are coming closer each other, and a is equal to minus
And
2, which is the
together,
break point. We together meet at this point, k equal to 4,
yes.
together
Yes,
break
sir.
point. Okay. Then what is
That's okay.
happening, there is
Yes.
a fight between sir and me. She is asking me where I will go, and I am asking where I will go. So let's have a collision. Those having higher power, it will reaches the pole which is nearer to 0 because he wants to have a minimum distance. Let me, sir is having higher power. So now he is moving to the right and reaches the ma'am here. Now I am having lower power, so I have to move up to infinity to find a 0,
To infinity.
right? So
Okay, sir.
now,
That's okay.
Okay.
now whenever SAR is moving to the right, when a SAR is moving to the right to approach k equal to the origin point, he is moving the right, okay, in this direction. And I am at
Yes, sir.
that same time moving in the left, right?
Yes, yes, sir. Yes.
For
Yes, sir.
both of the both are moving in the real axis at different locations.
Different directions.
Yes.
Different location also, sir. I
Okay,
am
sir.
moving the
Okay.
left side, you are moving on the right side, but we are on the
Yes,
same
sir.
real axis at different location.
Yes, sir. Yes,
So
sir.
in that whole range, tell me what is the k value? K value is 4 to infinity, here also 4 to infinity,
Yes, sir. Fourth.
Yes, sir.
right? When k value is from 4 to infinity, you are moving on the right hand side. Also, I am moving in the left hand side.
Yes, sir. Yes, yes.
So now this is overdamped, right?
Clear, sir.
Okay, sir. Okay. Now, okay, sir. Clear.
Now, whenever I am coming from this j root 2, you are also coming from j root 2. We are colliding at which point k equal to 4, right?
Yes, sir.
Yes, sir. Yes, sir.
So now at that two position, we are at the same position. When we are at the same position, this is marginally stable, or it is called critically damped, right, sir? Not
Critically
marginally
done.
stable. This is called critically damped.
Okay,
I'm
sir. Okay.
sorry.
Okay.
So at k equal to 4, this is critically damped. But now, whenever we are moving in the imaginary part, because whenever, sir, you are moving in this path, you are imaginary. Whenever I am moving in this path, I am imaginary. It means from k
Yes,
equal
sir.
to 4 to k equal to 0, this is imaginary, means under damped.
Yes, sir. Now,
How
okay, sir. Clear.
how simple this question, sir. You just have to identify at which location you are moving. That's it.
Okay, sir.
Okay, sir. Okay, sir. Thank you, sir.
You're getting this point.
Yes, sir.
Sure,
Yes,
So
sir.
sir.
in
Got it.
this
Got
way,
it.
ma'am, you have to solve all the questions. Okay. Maybe the root locus diagram, some person is still there in the next week. I will complete another some advanced level question I will do, and you will get a feel that how root locus will be actual can do. Okay. So I am stopping here.
Okay, sir. Okay,
Next
sir.
class onwards will start.
So you are not
Okay,
taking
sir.
classes, sir, further?
Sorry,
Oh,
ma'am. Sorry, sir.
next class, next tomorrow another person will take. That's the thing, sir.
Tomorrow another personal day. I'll take the next Monday, sir. Next Monday.
Okay,
same
okay,
slot.
okay, okay, right, right.
So the remaining
Okay, right.
portion of root locus will be covered and some other topics. I will give some advanced level of question. You will get a feel that how you can find out the root locus, how
Okay.
inverse root locus you can find out. Okay. So all these things will be discussed next class. Okay. Thank you. I am stopping here.
Thank you, sir. Thank you. Good
Thank
night,
you,
sir.
sir. Thank you so much.
Okay. Fine.
Okay, sir. Good night, sir.
Thank you, sir.
That's a good night.